Hi, it's Mr. Benson here with some examples from the previous algebra test that I'm going to work through just to help you understand where you might have gone wrong on these. Now, like I said in class last week, the main problems were to do with the key skills, where people are getting things like BODMAS wrong, directed numbers, like terms, those sorts of things are messing up your ability to get the answer right. So I'm going to do about 9 examples. I'm choosing the hardest one from each section just to show you the more complicated ones and working through each step. What I'd like you to do is to look at your tests as I'm working through these and try and figure out what you've done wrong, because I'll be expecting you to do similar questions on the actual test, which will be next week sometime. Okay, so get my pen ready. Moving on, so the first ones were just some simple simplifying questions. Now, with a question like this, when you look at all the terms here, they're all like terms. They're all Z terms. So all we need to do is think about how many we've got. Now in this case, which is a nice simple one, there's no negative numbers, so it's pretty easy. All we've got to do is add them up. Now remember that Z by itself is 1Z. So all you've got to do is add up the numbers. So we've got 1 plus 4 is 5, plus 5 is 10, plus another 10 gives us 20Z. So there's no multiplication in there. We're not going to end up with Z squared or anything like that. All we're doing is combining like terms. So remember what a like term is. Something with just Z to the power of 1 is a like term with something else with Z to the power of 1, and so on. Okay, so moving on, the next one, we had to do some substitution and then some solving. Now, this question was horribly done because people tended to mix up the expansion and the solving. Now, expanding is really useful, but if we know the values, and in this case we know P and we know Q, we don't need to worry about expanding this equation at all, because if we can evaluate what is in each bracket, then we're just going to end up with a number here and a number here, and we don't need to expand, we're just multiplying. So first thing I'm going to do is to substitute. Now remember, when you're substituting, you're going to put a bracket around the number that you're replacing with the pronumeral. Now the other thing to remember is when I'm saying P equals minus 2, the P disappears and is replaced by the number. You don't do something like P minus 2. The P is now defined, it has a value of minus 2, and so it's effectively gone from our expression. Okay, now that's one bracket there that I can evaluate, and then over here we've got our second bracket. Now this is really a heavily directed numbers focused question, and so that was probably the main mistake that people made. Okay, so have I done that right? I think I have. So I can work out either of these brackets, well, it doesn't matter which order I do it in, as long as I do it carefully. So I'll start with this one over here. Now I can ignore this bracket because it's only got one number in it, but I have to keep the negative sign on the 2. So I've got negative 2 plus 1. Now if you think about that one, the answer is negative 1. I've started at negative 2 and I've moved one step in the positive direction. So that first bracket is now done. But I'm going to leave the bracket around it until I've figured out this other one. Now over here, 3 times negative 5, we know 3 5s are 15, so 3 times negative 5 is negative 15. Now I did this first because multiplication comes before subtraction. So I need to worry about what's going on here, and remembering of course that 3 bracket negative 5 is the same as 3 times negative 5. So I get negative 15 and then minus 2. Okay, then I'm going to work down again. Now I'm not going to do anything with this bracket at the moment. I'll leave it as it is. This bracket here, negative 15 minus 2. Well, if I'm at negative 15 and then I go another 2 negative, I'm going to be at negative 17. Don't, in this sort of situation, think that this is negative 15 times negative 2, because you only have multiplication when it's outside a bracket, or if it's 3x or something like that, where we don't need to write the multiplication sign. So if you ever see negative 15 minus 2, or negative 15 negative 2, it's always just subtraction. Okay, so then what have we got here? Now we've got negative 1 bracket set negative 17. Now this is a situation where there's a multiplication here, even though we haven't written it. So we've got negative 1 times negative 17. Now 1 times 17 is just 17. Two negatives give us a positive value, so our answer is positive 17. Okay, simplifying. Now we're getting a little bit more complicated here because we've got terms that are not like. But all you've got to do is think about which ones are like. Now, in this case, I've got pq squared here and pq squared here. So these are like terms, this and this. So all I have to worry about really is thinking about how they combine. So I've got 11pq squared here, 11 of these, if you like. Then I'm subtracting 4 because the negative sign belongs to the 4. 11 minus 4 is 7, so I've got 7pq squared, and minus 3, there are no other numbers, so there are no like terms to combine with the 3. That's it. That's as simple as it gets. There's no multiplication or anything like that in this question. Okay, now this is simplifying, but it's just thinking about multiplication. Now, all you have to do here is multiply all the terms together. So let's start off with the numbers, because we can always evaluate numbers. So 4 12s are 48. Negative 4 times 12 is going to be negative 48. Now, I've got AB here, and I've got PQ here. So AB times PQ, we just write as AB PQ. So there's nothing tricky about this question. We're just writing it without the multiplication symbols, and where we've got numbers, we'll evaluate what they are. Now, it's probably worthwhile doing a slightly different example of this as well, although there actually weren't any in the test. But where you might get something that's a little bit trickier is, say we do something like 12ABC times 3BD. Now, the only thing that's slightly tricky here, now we can evaluate our numbers. 3 12s are 36. We've got A. The only tricky bit here is we've got B times B, and B times B, we don't write BB, we write B squared, and then C and D are unchanged. So the only time that it might get slightly tricky with multiplication is if you've got the same term and you're going to raise it to a higher power, so B squared in this case. And other than that, it should be pretty straightforward as long as you're careful with your directed numbers. Okay, now simplifying with division is trickier, especially when the denominator number is bigger than the numerator. So the way this one was written on the test was 12xyz over 144yz. So I'm going to start off with the pronumerals because they're probably easier to think about in this case. Now, if we do z divided by z, well, we know that anything divided by itself is 1. So when we're doing division, these cancel. So they effectively disappear. Now we've got y and y, they also cancel. So we're left now with 12 over 144x. So we've got no x's to cancel, but it would be nice if we could simplify this. Now, what a lot of people did is they, for some reason, just flipped this over so that it became 144 divided by 12. And that gives you the wrong answer because that's not what we're doing. We've got to think about what the equivalent fraction is here. Now, if you think about common factors, what number goes into both of these? Now, if your times tables are good, you should know that this is the same as 12 times 1 over 12 times 12. So 12 is the common factor that goes into 12 and to 144. Now 12 over 12, it's exactly the same as y over y and z over z is 1. So these cancel out. We're left with 1 over 12 times x, or you could write it as x over 12. You cannot write something like 12x because that's just wrong. If your 12 is in the denominator, it can't suddenly hop up into the numerator there. Just to show you another one that was similar, or people tend to make a similar mistake on, the previous question, 36 over 18z, well, there are no z's to cancel, so nothing can happen to our z, but you've got to remember this is in the denominator, so it's always going to stay in the denominator. So we'll leave it down there. We can simplify this. 36 over 18, well, that's the same as 2 over 1. So it's 2 over 1z. It's not 2z as almost everyone tried to write down. Now, because 1 times z is just z, we could write it as 2 over z. But 2 over 1z is the same thing.